We're going to talk about slope-intercept form in lesson 9.5. Slope-intercept form is a certain way of writing an equation. Let me give you a few examples of some equations that are in slope-intercept form and some that are not, and see if you can figure out, before I give you sort of the definition, see if you can figure out what slope-intercept form means. This is slope-intercept form. If we say y equals 2x plus 1, that is in slope-intercept form. If we said 2x equals 3y minus 2, that's not slope-intercept form. If we said y equals 7x minus 8, that is slope-intercept form. Y equals x is slope-intercept form. Y plus 4 equals 2x is not slope-intercept form. So maybe you've figured out that anything, first of all, has to have y all by itself on one side of the equation, usually the left. So that works. And the other thing is you have to have everything has to be simplified. And you can add or subtract something, but y always has to equal x multiplied by something plus or minus something. In general, y has to equal x multiplied by something, and we'll just use m for that. It could be any number, it could be a fraction. And then you can add or subtract anything. I'll just use addition. And b is any kind of number. Any rational number will work there. This is the definition of slope-intercept form, where you see y equals mx plus b. That's it. That, again, is a very famous equation. And it's famous because m and b represent something on a graph. M stands for, and does represent, the numerical value of the slope of the equation. It's the ratio of rise to run. And b is always the y-intercept. So if you knew you had, if you had like y equals 2x plus 4, you would know that at 4, that line, the graph, crosses the y-axis, and you'd also know the slope is 2, so you could go up 2 over 1, or you actually go, I don't have room to go up 2 over 1 on this, but go down 2 over 1, I didn't quite hit the spot, down 2 over 1, which is about right there. So this is just kind of sketching what the graph would look like. You know, you can tell right away whether it's a positive or negative slope by looking at the value of m. M is positive, it's positive 2 in this case, so we know that this line is going to go uphill. Let's take a look at a few. We're going to actually have about 4 or 5 equations I want to look at. So what we know from this equation, which is in slope-intercept form, is that the slope is 3, and the y-intercept is negative 2. So I'm going to make this a little bit bigger to work with. So I know I can, first of all, find the y-intercept here at negative 2. And then since the slope is 3, I can go up 3 over 1. 1, 2, 3 over 1. Then go up another 1, 2, 3 and over 1. And voila, I have the line. Kind of, again, a rough sketch of what that graph would look like. So there's the graph of y equals 3x minus 2. And all I needed to do on that was identify the y-intercept first, and then I can count up and over. It's actually 3 over 1. Go up 3 over 1 to put the graph in. Let's take a look at some other examples. Y equals the opposite of x. And this is kind of a cool one because the slope is actually going to be, you don't see a number there. So can you figure out what it is? It's the opposite of x. It would actually be negative 1. Because it's the opposite. We can put a 1 here. And then put 1 over 1. And we could also put plus 0 if we wanted to. That's the y-intercept. 0. So again, I'm going to make it a little bit larger here to work with. So the y-intercept is 0 right there. And the slope is negative 1, which I can count this various ways. I can go down 1 over 1. Down 1 over 1 would put me there. Another down 1 over 1 here. or I could go up 1 over 1 to the left. And different ways you can count it. But you know it's got to be a negative slope, so you got to think downhill. Going downhill. So just kind of logical reasonings know what it should look like when you finish up with it. Y minus 5 equals negative 2x, and say, wait, that's not slope-intercept form. So we have to do some work with that. What we're going to do is add 5 to both sides. And I put it over here because we could have put plus 0, the way it's written here. So this would, that would be a 0 pair. So y would equal negative 2x plus 5. And now it's in slope-intercept form here. So I can say the slope is negative 2. I can either write slope or write m. M is so, it's just so well known that m stands for slope in math circles that you got to get used to that. And then I could say b, standing for the y-intercept, is 5. So I'm going to go up 5, get my y-intercept right here. And my slope is negative 2, so I'm going to go down 2 over 1. Down 2 over 1, another one down 2, whoops, down 2 over 1. So here's my line. It's kind of fun. I'm sure you agree with that. Once you get the idea, they're very easy to grasp. And the last example I want to look at is, again, it's an equation that's not in slope-intercept form. So I'm going to have to add 2x to both sides to make it look like what I want it to look like. And that's a 0 pair, so I end up with y equals, and it's 3 plus 2x, so I'm going to use the commutator property and put the 2x first. So the slope is 2, and the y-intercept is positive 3. So what would it look like? So I'm going to go up 3. And my slope is 2, so that means go up 2 over 1, up 2 over 1, up 2 over 1. And this is what my graph would look like. So to review it, this is slope-intercept form. If you get the y-intercept first, if you're graphing it, whatever the value for b is, that's what you put at the y-intercept, and then just count up and over, or whatever value m is, and it's pretty easy to put them on a graph. Negative 2x plus y equals negative 3. Again, not slope-intercept form, so we have to get it in the form that y equals mx plus b. And here's how we're going to do it, is add 2x to both sides. So this would be a 0 pair, and y would equal 2x minus 3. So slope equals 2, and the y-intercept is negative 3. So I'm going to go to negative 3, and my slope is positive 2, so I can go 2 over 1, up 2.